Hey everyone, welcome back to the REST API in-depth series. In this video, we're going to go over HTTP headers together. This is something that we went over a little bit in the previous video. However, I really wanted to make a bit longer of a video on just this topic. This is something we're going to be using a lot. It's going to come up literally all the time, even in front-end work, back-end work. It doesn't really matter. HTTP headers are literally everywhere. And it's really important to know exactly how they work, the different kinds of headers, the different types of request methods, for example, like get, put, patch, all that kind of fun stuff. And the different response types as well, like all the different status codes as well, and a bit about the actual headers API, so we can actually learn how to use things like the fetch API alongside with it. So there's quite a lot to go through in this video. It's quite conceptual, but we'll see some practical examples as well, so I can't wait to get to it. Let's take a look together. All right, so to start, I just want to kind of give an overview of this idea of HTTP headers in general. Now, I'll show you some examples, so it's a bit more visual and we can see what's happening. But this idea of an HTTP header is that a client and a server can pass metadata around. Okay, so what does metadata mean? It just kind of means like extra information, extra data about the data that's not really relevant always to the data itself. So if you think about like, if I want to send back some HTML content to a client, there's a bunch of other information about that HTML and that request and response that might be interesting. For example, the date and timestamp that it was requested, or maybe even last updated, whether that was cached or not cached. There may be the operating system or the server name and things like that. There's a whole bunch of stuff in there that is just metadata that goes around these requests and responses that's important and sometimes necessary even to know, as we'll see shortly with different types of request methods. We saw previously that there was this idea of HTTP headers when it came to things like the IP headers and TCP headers and UDP headers when we looked at protocols. So this is kind of a little bit of an addition on top of that. This is actually working with things like the request object and the response object as well a little bit, but we're going to be mainly dealing with HTTP headers in the context of the backend for the most part, because we're going to be reading them and responding to them, but we'll see a bit of how it works on the client side as well with things like on Insomnia. So request headers are, as you probably can imagine, things that go along and the metadata that goes along with the request. Okay, so if I'm requesting for content, I'm going to be sending some metadata along with that request so that the thing making listening for that request and about to respond has some extra information for it. So in this case, usually it's a client talking to a server. So we're going to be a client, maybe Insomnia, maybe the browser, and we're going to be requesting content from a server, and that server is going to read that metadata and then respond accordingly. The inverse of that, or kind of the converse, I don't really know the right word there, is the response headers. So when the server replies back to that request, it's also going to send some extra information with it. And it might be things like, hey, here, I use some compression. This is the compression method that I use, so you can decode it yourself. This is the length of the content and things like that. So these are all kind of split up into different types of headers as well, apart from requests and response. There's things like representation and payload headers and things like that. I don't want to get too deep down that rabbit hole, because really all that matters for us, for what we need to be building, at least at the start, is that there is headers that go along with HTTP requests and responses, and we can get access to them through the request and response objects and things like JavaScript and other languages. And it is a standard web API, so it's quite nice. And there are some specific terminologies that we'll need to know in order to understand how it works. And some of that comes from a bit of the protocol stuff, and some of it comes apart from that. Yeah, most programs have some defaults for these that I'll show you in a second, but let me just show you a visual just so this makes sense to start. So this is an example of a whole bunch, it's a bit small, so I apologize, a whole bunch of just like random key value pairs, not really random, but this is just one particular example. Most of our requests are not going to look like this, but this is one example of, I think in this case, it's Chrome. I'm making a request to youtube.com. And we can see some information about that request in the context of Chrome making that request on my behalf specifically, because I was the one who asked for it. So if we take a quick look through here, we can see things like there's a method in here, which we'll look at shortly. I know this is a bit small, so I apologize, but we'll see some examples together in a second. There's some path, in this case, the root path. So I just went to youtube.com/. We can see the scheme or the protocol in this case is HTTPS. We see this thing about accept and accept encoding. So kind of like what are the things that a browser is okay responding or having as a response? Is this cached or should it be cached? What are cookies? You might have heard that before. There's a whole bunch of other stuff in here that has to do with Chrome specifically, and this depends on what type of client specifically we're using to make that request, because it's the client that adds these things to the HTTP headers for the server. So the kind of the opposite of this is the server side, right? So the server is going to respond to that request. And these are called response headers. These are headers. They look the same. They're just key value pairs. It's always just key value pairs. And these key value pairs are coming from the server. So in this case, this is the response from that request to youtube.com through Chrome. So in this case, I'm assuming that this is somewhere in Google's network on one of their servers, and their server is set up to respond in this particular way to this particular client requesting for this particular site, youtube.com. Okay, so this is Chrome requesting for youtube.com from Google. You can see that we got some accept headers, some caching stuff in here. It's giving us some information on the date, for example, and when this should expire. There's some permission stuff and some cookie, and it tells us a bit about the server type and things like that. So, I mean, like some of this is pretty useful, right? Like, for example, we'll see content type is a pretty big one. That's pretty important to know, especially in the context of us being one needing to send these responses. So this is saying that this is HTML, for example, and the actual encoding as well, which is UTF-8 in this case. So that's useful to know for the client. And we'll see why later on. So hopefully at a very high level, this kind of makes sense. And I want to show you a live demo of this really quick before I show you a bit of the headers API itself. So I'm going to switch over to my browser. I'm going to pull up Google. I'm going to right click and I'm going to click inspect to open up the dev tools. And in the dev tools, what you can go is over, there's elements, console, network, application, things like that. Most browsers should have this. Or you're using something like Firefox or Safari. It should look very similar to this. Let's go to the network tab. This is a tab we're going to be using a lot in this course together in the context of the browser specifically, but mainly we're going to be using Insomnia. If I reload this page, what's going to happen is we're going to be making a request out to this website, and we're going to be seeing kind of the request headers and the response that comes back for that request. So I'm going to refresh google.com here. And what we'll see, if I scroll to the very top, you might have different results than me, but what we'll see is at the very, very top, what you'll usually see is this one. Oops, let me just kind of make this a bit bigger so we can see this. You'll see google.com, right? At the very, very top. That's usually the first request that we need to be making is to something like the actual root URL, in this case, google.com. So if I click on this, what we'll see is that there's some information here. Specifically, it actually says headers. It says headers right here, which is pretty cool. If we scroll down here, we can see that there's general headers. There's things like the request URL, google.com, the request method, the status code. We'll talk about that in a second. The address, or the IP address. So you can see that we're talking to this IP at this 443, which we know is for HTTPS traffic or HTTP over TLS. There's some response headers over here. You can see a whole bunch of stuff that is being sent by the Google server in this case. It looks like there's some encoding, the length of the content, in this case probably in, I think it's in bytes, and a whole bunch of other stuff. You can see that's HTML, there's some data information, there's some server information, GWS. I'm sure you could Google for what that is. That's probably their own internal version of their server. So that's all the request headers right here, or response headers right here. So this is what Google is sending back to us. You can see there's 25 of them from their server. Similarly, we have request headers right here, and there's 28 of them. Well, you're probably thinking, wait, like where did these come from? We didn't set these. Well, Chrome in this case is setting them for us automatically on our behalf to make it easier for other servers to understand that we're requesting this from a web browser, in this case from Chrome. So you can see that we're making a GET request. The path is to the slash, which means the kind of the home page. We're doing HTTPS as our scheme, where we can accept, it's a bit cut off here, but a whole bunch of different encodings or types of content, I guess, in this case. And there's encoding. So for example, the compression in this case, which we'll see a little bit when we actually do this ourselves. The language in this case is English. Caching information, cookie information, a whole bunch of other stuff in here, not that interesting for us right now. And at the very, very bottom, we have the user agent, which is telling the server kind of like the fact that this is Google Chrome, and it can differentiate between different types of browsers. So if we were doing this on a mobile browser, it would look slightly different for a user agent. This is the thing that identifies the client most of the time. So if I switch over to Insomnia, I'm going to create a new collection over here. Actually, I have a previous collection here. This is REST API in depth. I'm going to go to that one. I have a request. If you don't have one, go ahead and click the plus button, click new HTTP request, and I'm going to rename this. I'll call this Google, I'll do headers. Why not? And I'll say, I want to go to google.com. Okay, I'm going to press enter. I don't think I need the HTTPS there. It should do it automatically, and I'll click send. And we'll see that we get back google.com. You can see now that there is a headers section here. So if I click on that, you can see that we'll get back all these different headers. I actually can't move this over, so it's cut off a little bit. But these are very similar to the ones that we saw in our browser. They're just slightly different. So it looks like we're getting responses in this case, differing responses from the Google server depending on what client we're using, which is kind of interesting. So it knows whether we're using a browser or not. So that's pretty cool. Also, we can set our request headers in this case. You can see that if I click up here in the top section, this is the request headers, and we're sending one header, the user agent Insomnia, and we can turn this on and off to send that or not send it depending on what headers we want. We can add more over here if we want by clicking add, which we'll do later on. But these are the request headers up here and then the response headers down here. And you can see we're getting things like 200 OK. And if you click on the timeline, you can also read them in this format if you like. There's a little bit of information there about those headers and then these headers as well. All right, so that's a bit of a demo of how the headers work. And we're going to be working a lot with this, but it's important to get very, very familiar with the idea that we're sending a request. The request has some metadata along with it, no matter which client we're using. And then the server can read that information in the header and then respond with its own response and its own headers that the client can then kind of vice versa read and get some information about that data. Okay, so I'll switch back here. I want to show you something really cool. I'm excited about this. You don't see this very often, but it's very important. We're going to be using it a lot because we're going to be focusing on the web standard APIs, and we're doing everything kind of from scratch in this course to really understand how the web works. So the Fetch API, if you've heard that or have used it before, is built into kind of most browsers, even things like Node.js these days and Deno, as we're going to be using as well later on. Actually, we're going to be using it in a second. I'll show you how Fetch works with the headers object. It turns out that we can create headers in JavaScript, and we can attach them to our Fetch requests so that they get attached to that Fetch request, just like it would get attached to a Fetch request from the browser in this case. We can attach our own headers, or an Insomnia is attaching its own headers here in this case, for example, a user agent. And we can add and remove them. So it needs a way to attach more headers or remove headers. So we can actually do that ourselves in code, which is quite nice. We have direct access to manipulating these headers for each request and for each response, which is pretty nice. So let me show you what I mean. I'm going to switch over to Google or VS Code here. I have a folder open and it's a blank folder. So open a blank folder. And previously we saw that we can create a Deno workspace and get all the nice autocorrect stuff going for us. I'm going to type Deno up here. We're going to get initialize workspace configuration, Deno linting. I'm going to say yes. Deno unstable APIs. I'm going to say no. If you don't have that option, and when you do a Command Shift P or Control Shift P and type Deno, just like I did here, and click on initialize workspace for Deno, that means you don't have the extension for Deno installed in the VS Code, and you're probably going to want to go over to extensions and install the one from Deno land, as well as Deno itself if you don't have that installed. Then I'm going to create a new file. I'll create a server, or in this case, I'll just do headers. Servers is for the next video, .ts. And I want to show you something really cool. So I'm going to say const headers is equal to new headers, just like that. Okay. Now, if I hover over this is one of the nice things, many nice things about Deno is that everything's typed. So we get information about this headers interface, which is part of the Fetch API. And we can get a lot of information in here about it. But what's more interesting is if we look at this on MDN. So let me go over to Google Chrome. I'll go to Google over here in a different tab, so I don't have the whole network thing open. I'll type on headers MDN. And you should see this headers web API for MDN. I'll click on that and I'll zoom in on this. I highly encourage you to kind of read through some of this at the very least. There's some cool stuff in here about things like forbidden header names, forbidden response header names, request and response header names. It gives you a bit of information about all the different methods in here, and we're going to be using these a lot. And a bit of a detail of how those work, as well as some actual examples. So I'll show you the basics of this, and we'll actually start using this more and more as we actually build this out ourselves on the backend side of things. But I encourage you to read through this because it actually has a lot of nice data packed in here, and you actually learn quite a lot about how the web works, as well as the fetch API. So this is part of the fetch API, which you're going to be using because it's a web standard. Now, what's pretty cool about this is I can say headers dot, I can append, which means add to the end, or I can set one, and this will overwrite one if it exists. But for example, I can set like the content type header, and that might be like text/HTML. Okay, and I'll console log out these headers. So I'll say console.log, and I'll say headers, and I'll run this. And in my terminal here, I have a terminal open. I'll make sure I'm in the correct folder here, ls headers.ts, and I'll say Deno run headers.ts, and you can see that we have a headers object, which it looks like a regular JavaScript object, but it has some nice. It's a class that has a bunch of nice stuff in the interface that we can use, like we just used set, and it's setting the content type to text HTML in this case. Okay, now it's probably confusing as to what this does and why this is useful right now, but we're going to be using this to actually tell our clients the type of our content. So for example, in this case, this is a very important header that we're eventually going to have to learn, which tells the client, hey, by the way, this is not JSON. This is HTML. Or we could say this is JSON. This is not HTML. And then the client can react accordingly, according to that data type that's being sent back to it. Because if you think about it, there usually is no like file types and things like that when it comes to HTML requests and responses. We need to kind of have the file type or the content type sent in the header in this case. And this is effectively the same thing as like a JPEG, for example, as a file type. So we would send this back to the client, and then the client could actually interpret it in its own way or visualize it differently depending on if it's JSON, for example, or HTML or just text content. It could visualize them all slightly differently. So we can add multiple headers like this, and we can append them, we can delete them. There's a lot of really nice things in the interface. If I do headers dot, you can see that we have a lot of different stuff in here, and this should match what we see on MDN. I highly encourage you to play around with this and get more practice. It wouldn't make sense for me to make exercises for this video. We're going to get to that in the next video where you'll see more practice with this. So just to get a head start, I encourage you to practice around just by setting them, deleting them, looping through them, and logging things out to see how it actually works, and also reading the MDN page. So just for a bit of a teaser as to how this works, we would fetch a URL, for example. So we do like www.google.com, and then we would be able to set an options object here, and we could say headers would be these headers, for example, right? And if we want to be fancy with ES6 syntax, we could just do headers just like that. Okay, and this is going to set these headers here, these headers right here for this particular fetch request. And we can set different headers for different fetch requests. Sometimes you'll see people just use an object instead of like this headers object. However, this has a really nice API and some other fancy things in there that makes it much easier to work with in the context specifically of headers. It's a data structure meant exactly for that purpose. Okay, so hopefully that one makes sense. That one's a lot of fun, and we're going to be using that extensively. The next thing I want to cover is request methods. So we saw a little bit of this, and the idea behind this is that every request kind of has an intent. It has some kind of intention. And most of the time, it's some kind of operation that we want to perform. So most requests have a part of the header that is called the method. And we're going to be using this literally everywhere. Like, in fact, I'm probably going to be making a video on get, a video on post, a video on put and patch, and then a video on delete most likely. I might do the others. We'll see how it goes. But these are so important and so central to the idea of REST specifically that we need to know them almost inside and out, at least from a terminology perspective. how they work is pretty much the same. They all just use HTTP, and they're just setting a like this word specifically in the method. But we'll quickly see that each of these means something very different. So the GET request, this is probably the most common one. We'll go over these in detail in their own respective videos, but I'll just give an overview really quick just so we have a bit of an understanding of what these are. A GET request is signaling that we want to get content from or some kind of resource from a remote server. So I'm going to say, get me like, JSON for this, or get me this JPEG file, or get me this HTML file. That's what a GET request usually is. So I'll show you what I mean. If I go over back to Chrome and I pull up that Google request that we saw earlier in the network tab, you can see right here, the request method was a GET request, right? I'm asking for the content at google.com/. In this case, the response is this HTML, and it looks like this. It looks, well, I guess I'm missing the Google image right there, but you can see that this is the HTML response, and there's a status code, which I'll show you shortly. But this is the important part right here. This is a GET request. There are other types of requests that are not GET requests, and GET is one of them. And just to kind of hammer this in, if I switch back to the fetch API here, and I do a comma, and I do method, we'll see that we can do many different methods here. So for example, there's like get, there's post, there's patch, there's delete, and we can pass that into the fetch API as as specifically the method used for that fetch request, which is pretty nice. So let's keep going with this. So this is to fetch content. Post is for us to create new content. So this is very important for REST API. So for example, if you imagine that we want to, let's say, register for a new user. If that user doesn't exist, we want to create that user. We would usually do something as a post request, where we would create that user. Or let's say we're creating a new comment in a comment feed, or creating a new picture in a picture feed. We're adding that as a new resource to that resource, that list of resources. So that would usually be a post request, and that post request is going to have the content for that new resource inside of it. Put and patch have to do with updating resources. So that would be like, for this particular resource, I want to change the title. Or for this particular profile, I want to change like my last name, for example, right? Or my age. And that would be a put or a patch, and they work slightly differently, and we'll see those in their respective videos. Delete is pretty self-explanatory. As you can probably imagine, that means I want to delete that particular resource. So if I say I want to delete a user with user ID, for example, 123, then I would delete that user and it would no longer exist. So if I tried to get that user later on, it would just say like something like not found. Okay. Head and options are pretty interesting. Head allows us to check for the headers that would normally be returned, but without doing a full GET request. So let me show you what I mean, practically speaking, by actually using the Pokemon API really quick. So if I go to Google here and I grab Pokemon API, if I Google for Pokemon API and I go to that web page, which is the first result there, I'm just going to grab the this URL right here, direct link to results. So if I scroll down slightly, you'll scroll down right here. I'm going to grab this link, copy link address, and I'll switch to Insomnia. I'll do a new HTTP request, and I'll rename this one, and I'll just say Pokemon API, and I'll paste that in here. Okay, and I'll click on send. And what I'll get back is some JSON data. And just to show you a little bit of detail on the headers here, if we come down here, we can see that the content type for this is application/JSON. That is the type for JSON data, and that's why we can show it in this format. Now, this is all pretty useful. This was, as you can see, a GET request. You see where my mouse is kind of circling around. Right here is where we can put the method for the request. And this method was set by default to be a GET request because that's the most common request. But if I click on this, you can see that there's all the options that I mentioned, as well as custom ones if you need to create your own custom ones for your own applications. But these are the core ones that are part of the standards. So get is, we just went through that. That means get that resource. You can see that we actually get back 22.7 kilobytes of data for this resource. So that's quite a bit of data. And it's 200 status OK, which we'll see shortly. But if I switch this to a head request, you can see that switches it over to the head. Let's see if that reduces the amount of data that we get back. So there's 23 headers, 22.7 kilobytes. I'll click on send, and now you can see that I get 0 bytes of data. Because there's no actual content in this body. This is just headers being sent back and forth. However, I still get back those 23 headers, right? And if you switch back and forth to get and head, what you'll see is that all of these are going to be the same headers as the get request, but it's without the actual content. So why is this useful? Well, it's useful for us to know, for example, maybe sometimes we get back the length of the content as a header, or we get back the different supported types, or we get back like what kind of server is being used and things like that. There's a few reasons why you would use head. We won't get too deep into it. Just know that it is there and it's short for kind of headers, just so that we can request the headers for that route or for that resource specifically without actually needing to fetch all that content. For example, if this was a gigantic file or it was like a very large JSON thing or a huge web page, we can just ask for those headers and then we can deal with actually making the request later if we want to. Now, kind of another version of this is what I have at the bottom here, which is the options. So let me switch this over to options and let's see kind of what the difference is, and I'll kind of give us some examples of where this would be useful as well. So instead of head here, I'll do options request to Ditto, and I'll click on send. And once I do that, you'll see that I also still get 0 bytes back. The headers change slightly, so I'll click on the headers here. And the most important thing right here is this one. Let me see if I can make it fit on my little screen here. You can see there's get, head, put, patch, post, and delete. There's this thing called access control, allow origin, as well as a couple other headers that weren't there before. Now, this is the main point of options. Options is a header or is a request method that allows us to kind of query for the options, which are the different methods and things like the cores headers and things like that for the actual resource that we're looking for. This is most often used for things like cores, which we'll cover in a separate video, which I know is a lot of the time very, very confusing because of kind of the fact that it blocks a lot of people from APIs, but it does make a lot of sense once you dig into it. What's really nice here, though, is that we also see all the supported types of operations for this API. And in this case, the cores headers are set to everyone is enabled to fetch from this API regardless of the domain, which is quite nice. So we'll see a bit of that later on. Just notice that mainly options is to query for the supported types and things like cores requests. Head is specifically for, I want, as if this was a get request for that resource, but just the headers without the content. The get would do the same thing as the head, but would actually fetch the actual content as well, which might be a bit large depending on what type of content you're fetching. Now, if I do a post request to this URL and I click on send, you'll see that nothing happens. 404 not found, which we'll actually see shortly. The status codes are. Same thing will happen for patch, put, and delete. This API is really just to get information from, hence why it supports the get and the head and options as well. Okay. Now, we'll go over these in detail in their own videos, but hopefully that's a good overview for you. To wrap up the video, I do want to go over the status codes. Now, the status codes are kind of like the, almost like the opposite of the method to some degree. It kind of tells us what happened. I have a typo in here. What happened with my request, right? So I would be able to say, it's like maybe this was successful, maybe it was not successful, maybe there was an error that you made as a client, maybe there's an error that I made as a server, something went wrong, it crashed, what have you. Things like that are status codes. Now, you might be familiar with this to some degree depending on what types of browsing you've done, and if it's on a desktop or a mobile, and if you mainly use apps or if you do use the browser a lot. A very common one that people will see are ones in the 400 range, things like 403 or 404 not found. So actually that's what we saw together. If I switch over to Insomnia, if I make a, like for example, a patch request, which is not supported, to Ditto here, and I send it, we get a 404 not found. And if I hover over here, you can see that server cannot find that resource. But if I do a get request, you can see that I get 200 OK, which is in the OK range. If I do a head request or an options request, it's slightly different. In this case, it's a 204 no content, which kind of makes sense. Like there's no content that we're getting back, but we're getting back just the headers. So there's all this sort of extra information that is encoded into these status codes that are all standardized and give the browser or the client a little bit more information about what actually happened with that request. Now, I'm going to show you something. If I go over to Chrome, I'm going to go to Google. I'm going to search for HTTP status codes. And if we go to usually the top result is HTTP response status codes from MDN, Mozilla. If I click on that one, and I zoom in a tiny bit here, we'll see the HTTP response status codes. You can see that that's exactly where I got those from. And if you go through this page, I would highly encourage you to scroll down through this page. For example, I'll go to the 400 section here. You can see that there's bad requests is 400, unauthorized is 401. Forbidden is 403, not found, which is a pretty common one, is 404. I can't find that resource. And we're going to want to be able to make sure that we set the correct status codes for our clients as well, because now we're going to be the ones building these REST APIs. And for example, if our client makes a request to a resource that we don't support, or a URL on our backend that doesn't exist, or a request for a file or some content that's just not there, we would like to tell them. We'd want to tell them that, oh, I'm sorry, like that's a 404, like it's not found. So they know that that's their fault, that they're requesting for something that doesn't exist. Now that's a bit different. If I scroll down here to the 500 errors, right, the server response errors, you might see 500 sometimes, or 502, bad gateway. This means that the server had an issue. That's not necessarily the clients that made an issue. It maybe our code on the server went wrong, or maybe something with our database went wrong. Usually we don't want to reveal too much information for safety and security reasons, but it gives the client a bit more kind of information that it's not really their fault. It's kind of like our fault as a provider or as a service for that REST API. So yeah, there's a lot of cool stuff in here. I encourage you to read through some of those status codes, as well as the different request methods, as well as the headers API and the fetch API if you haven't done that before. And you can play around with what that would look like by adding these to the fetch options after the first argument here is the kind of different options like the headers and the method and things like that. Our backend is going to be able to use fetch. The front end can use fetch. This is the nice thing about using the same API and the web standards across the backend and the front end. This is kind of all the dream. This code would run in the browser just as much as it would run in something like Deno, which is quite spectacular. So there you have it. That's pretty much everything I want to show you with HTTP headers. And we're going to be working with these a lot and get a lot more practice with these. But at the very, very least, this is the information that we're going to need to get started. I hope that you found this video valuable. If you did, I'd love it if you could like the video and subscribe to the channel as well. I have a Patreon set up if you want to help out that way, or YouTube memberships and super thanks. I would appreciate any of those very much. What we're going to do in the next video together is finally start coding our first Deno web server. And we might add a couple other types of servers and data types that we might send back, like files and HTML and stuff in there, just so we can see a bit of difference before we go full on down the JSON REST API route. And we're going to get that coded up. We're going to see how these exact concepts and everything that we learned up until now, things like ports and the URLs, and just general networking basics, plus these headers are going to start coming in handy more and more as we start even building out a very basic version of that and then build on top of it. So I can't wait to get to that content. I will see you there.